Hello, I'm Todd Miller from ElectroRx, here to talk a little bit about our Telelogger board, an extremely useful, fully integrated data logging system, Internet of Things systems for reading sensors and sending data to the internet. At the heart of this board is the SAM21 microprocessor, really useful, low-powered microprocessor, lots of code out there for using it, free libraries. We provide our own example code for programming it with this particular board. Now, down on the bottom, we have screw terminal ports for attaching sensor wires. This system is capable of reading virtually any sensor on the market. Typical sensors like temperature, humidity, wind, full data sons that measure conductivity, water quality parameters. Really any kind of sensor you can think of can be used with this board. Powering the sensors, we provide three power rails at 3.3, 5, and 12 volt. The 3.3 and 12 can be turned on and off in code to save power for long-term applications. Now these screw terminals are really useful. Instead of soldering wires directly to the board, we have these plugs that just come off and you can screw in your wires and then plug them back in. Since you're not soldering them onto the board, if you choose to reconfigure the system for different applications, then you don't have to try and desolder wires and resolder them back on. It kind of makes a mess. So those screw terminal ports are really useful. Now, as I said, the board is programmed using the SAM21 microprocessor. You can program it through the USB port. It has a bootloader loaded onto it, so we can use the Arduino IDE or various other kinds of software for programming it. The microprocessor reads the sensors that are attached, and then we have a choice of what we want to do with the data. So we can just save the data locally onto an SD card, or we have three different methods for sending the data to the internet. Over here is a very popular Wink 1500 module. So I've got the UFL antenna attached here. That particular Wi-Fi modem has, there's just tons of libraries and code out there for using. It's very easy to use. Again, we have some examples in our Learning Center for how to use it. For more mobile type applications, maybe the more popular is a cellular modem. This is the Airgain cellular modem. It's their BG96 version, the Quectel BG96 modem that can be programmed using AT commands. Again, we have various example code for using it to send data to the internet. It also provides GPS location information, which can be very useful in these mobile type applications for tracking your system. Now, underneath the cellular modem is yet another option for sending data to the internet, and that is a rack wireless LoRa modem for sending data using long-range radio communications. In our Learning Center, we have examples of sending data to various online databases, routing it through the Things network, which is necessary for the LoRa modem. The other thing is that you will need a nearby gateway to send the data. There's various affordable options for setting up your own gateway, but a becoming very popular communication method and people setting up their own public gateways throughout the United States. They're very popular in other countries as well, such as Europe. So look for gateways in your neighborhood, and you might already have one available to use that communication method. Now, if you don't want to use LoRa or Wi-Fi, you can just turn them off with this dip switch over here. Or if you don't want to use cellular, but you do want to use LoRa, you can turn off the dip switch for Wi-Fi. Just unplug and don't keep plug in a cellular modem, and just turn on the dip switch for LoRa if you just want to use LoRa. Now this board's meant for mobile applications, so we have place for powering the system with a battery, accepts a 3.7 volt LiPo battery, in this case the blue pack, this one from Adafruit. We have various other kinds of recommendations for batteries to use. Board is also meant for long-term unattended applications using a solar panel. In this case, the board can accept any solar panel that provides less than 10 volt peak output. Now the battery can also be charged using the USB port. So you can either plug the USB cable into here and the other end into your computer, or plug it into a wall wart, and that will also charge the battery. So for example, if you're programming the board using your computer, you have battery plugged in, you're already charging the battery, and it'll be ready for that deployment once you want to put this in the field. This whole system, typically we package into a weatherproof enclosure, such as from Polycase, and then route sensor wires through the housing using either cable glands or some other connector that provides a dry connection. So that's it. This has been a very useful board for us. Been using it for the last 5 to 10 years, building systems both on land, in water, in buildings, on vehicles, you name it. It's been extremely useful for us in a variety of different applications.